Imagine you are on a banking app. You've made a withdrawal. You have the money in your hands, but the app doesn't reflect the difference in the balance. It still shows the original amount. Or you have commented under a YouTube video and you went to a different tab. You open the same video, but the comment doesn't appear there. Or you have added an item to a checkout list, but the checkout list doesn't properly update your previously added items in the list. This is a system design issue, and depending on what angle you take from it, one particular problem that this results from is replication. What is replication? Replication is the ability to duplicate data across multiple state machines. We have different types of replication. We have single leader replication, multi-leader replication, and leaderless replication. Single leader replication has one node that accepts write operations. Then this node takes this write operation, appends it on its write append log, then later takes this updates and populates it on the other replicas. Multi-leader replication is similar to single leader replication, but instead of one leader, it has multiple leaders that accept write operations, and these leaders take the operations and update their replicas independently. This is generally used in organizations that have data centers across different geographical locations. So these leaders that are sent in each data center takes the updates and resolve the conflicts in data objects across the region. Leaderless replication is a type of replication that is different from the first two. It's a replication that has no leader. So any node across the data center can accept write operations and read operations. So in this replication, any node can act as a node that receives write operations, and the changes are then used to update other nodes in this particular replication system. What are the importance of replication? Replication gives you certain benefits that we cannot do away with in the context of designing a system. Replication gives you high availability. So if you want your data to be highly available to multiple people in multiple regions, a good way to achieve this is to have replicas across different regions which are closer to the people you want to see the data. This is the reason why replication is important in this context. Another reason is for backup stores in this system designs. So you have replicas so that the data survives in case of a catastrophe for high fault tolerance. Another reason for replication is for multiple nodes to accept write. So for example, if a person writes to a particular node in the data center, and the node for some reason fails to replicate the data, other nodes could in turn have this data also. So if a user writes data to a node, the data survives regardless of what happens. Here are certain applications that benefit from these types of replication mechanisms. For single leader replication, we have banking apps, ride sharing applications, and any application at all that requires strong consistency across nodes. For multi-leader replication, a classic example is Google Docs. Google Documents allows for multiple people across regions to make changes in one particular document. So depending on where the users live, they may be writing to different leaders or different data centers depending on where they live. So these changes are then committed to their data centers and later resolved. This is an effect that is hardly noticed due to the speed of the current internet connections, but in the background, the changes happen instantaneously, so you do not see the lag in the conflict resolution across these data centers. For leaderless replication, we have applications such as e-commerce shopping carts that benefit from this high availability. We have Netflix watch history. We have high distributed chat logs that also benefit from this. So any application that requires high availability, example is Facebook or Netflix, most certainly use leaderless replication in their system operations. Examples of databases and the category they fall under So in single leader replication, Postgres is a classic example of a database that uses this mechanism under the hood. For multi-leader replication, we have an example like Coach DB, and for leaderless replication, we have Cassandra and DynamoDB. So these are examples of databases that uses these types of replication mechanisms. So when designing an application, one thing to take into consideration is availability, consistency, and one other thing is partition tolerance. A way to get the first two is by replication. So depending on the type of replication mechanism you use, you are going to get a highly linearizable system or a highly available system. So take this into consideration while building your next projects. Thank you again for this video. I'll end it here and have a blessed day.